Greetings everyone. Welcome to another episode of High School Mathematics. In our last class, we discussed the operations of number bases, addition, subtraction, and multiplication. In today's class, we continue from there to discuss division in number bases. How are we going to divide two numbers of the same base? For example, we have 11011 base 2 divided by 11 base 2. To carry out this operation, we use long division. Before we continue, one important thing to note is the divisor. This is our divisor. What are the digits used in base 2? Because these two numbers are in base 2. What are the digits used in base 2? We have 0 and 1. We are going to multiply the digits used by the divisor. 11 multiplied by 0. 11 multiplied by 1. Now we continue. The first digit, 1 divided by 11, that is not possible. So we have this to be 0. We will now take the first and the second digits together. 11 divided by 11, that is 1. What we are going to do next is 11 multiplied by 1, that is 11, and then subtract. 1 minus 1, 0. 1 minus 1, 0. We bring down the next digit, which is 0. 0 divided by 11, that is 0. 11 multiplied by 0, it will give us 0. We bring down the next digit. 1 divided by 11 is not possible. We will write 0. We join the next digit with this to make 2 digits. 11 divided by 11, that is 1. Now, 11 multiplied by 1, we minus. 1 minus 1, 0. 1 minus 1, 0. This means that 11 base 2, we divide 11011 base 2 without any remainder because we don't have any digits here aside the zeros. The result of this is 11011 base 2 divided by 11 base 2 is equals to if the first digit is 0, don't write it. If you have this to be 00101, we are not going to write the first zeros. We have 00, we are not going to write it. Start from the non-zero digits, that is 1001 base 2. The second example. Also, the divisor is 11 multiplied by the digits used. The first one is 1 divided by 11, that is 0. It's not possible. We join the first 2 digits together. 11 divided by 11, we have 1. 11 multiplied by 1, that is 11. Subtract 0, 0. We bring down the next digits. 1 divided by 11 is not possible. We will write 0. We bring down the next digit. Now this is 10. 10 divided by 11 is not possible. We write 0. Instead of the 2 digits, we now have 3 digits. 101 divided by 11. This is where we now come to this side. Oh, sorry, this should be 11. Can you see 101 here? No. What we have here is 0 or 11. That means that in 101, we are going to get just 1 11 there because we have 11 times 1, and that one gives us 11. That means 101 divided by 11 will give us 1, remainder something. So we write 1. 11 multiplied by 1, that is 11, minus 1 minus 1, 0. 0 minus 1, that is not possible. In our last class, we said we borrowed 1 from the next digit, and this is 0. The one that we borrow, we turn to the base. The base we are working with is base 2, and we have this to be 2. 2 minus 1, that is 1. This means that 11101 base 2 divided by 11 base 2 will give us 1001, remainder 10. We have this to be 11101 base 2 divided by 11 base 2. This is equals to, since the first digit is 0, we are not going to write it. 1001 base 2, remainder 10 base 2. Next example. That is 110 base 2 divided by 101 base 2. Long division method. 1, the divisor is 101. Again, the digits used in base 2 is 0 and 1. 101 times 0, this is 101 times 1, 101. We start from the first digit. 1 divided by 101 is not possible. Join this together again. We will join the first and the second one together. This is 11 divided by 101. It's not possible. We join the third one. This is 110. 110 divided by 101. Come to this table. Do we have anything like 110? No. That means that we can only see 101 in 110. And we have this to be 1. 101 multiplied by 1. That is 101. Subtract. 0 minus 1 is not possible. We borrow 1 from the next digit. If we borrow 1 here, this will be 0. And the one that we borrow will turn to the base. The base we are working with is base 2. We have this to be 2. 2 minus 1. That is 1. 0 minus 0, 0. 1 minus 1, 0. We bring down the next digit. Now, 11 divided by 101 is not possible. Write 0. Bring down the next digit. 111 divided by 101. Do we have 111 here? No. What do we have? We have 101 times 1 equals to 101. That means that we can only see 101 in 111. So that means we have 1 here. 101 multiplied by 1. That is 101. We subtract again. 1 minus 1, 0. 1 minus 0, 1. 0, sorry, 1 minus 1, 0. We don't have to write the last, this one. We bring down the next digits because our divisor is of 3 digits. We bring down the next digits. 100. 100 divided by 101 is not possible because 100 is less than 101. That means this will be 0. We bring down the next digit. Do we have 1010 here? No. Sorry, 1001. No. That means that I can only see 1101 in 1001. This will be 1. 101 times 1, 101. We still subtract. Now, we bring down the next digit. 0. Do we have anything like 1000 here? No. That means I will only see 1 of 101 in 1000. and we have this to be 1. 101 multiplied by 1. This is 101. Now, 0 minus 1 is not possible. We borrowed 1 from the next digit. We don't have anything to, we cannot borrow 1 from 0. We cannot borrow 1 from 0. We come to this side. Borrow 1 from this 1. This returns to 0. The one we borrow returns to 2. 2 plus 0, that is 2. We borrow 1 from that 2 again. This returns to 1. And the one we borrow returns to 2 plus 0, that is 2. We still borrow 1 from it again. This also, we will also have 1 here. The one we borrowed, we change to 2. 2 plus 0, that is 2. 2 minus 1, 1. 1 minus 0, 1. 1 minus 1, 0. This one is already 0. We have this. That means that 1, 1, 0, 1, 1, 0, 1, 0 base 2 divided by 1, 0, 1 base 2 is we have the first 2 digits to be zeros. We are not going to take this. We start from 1, 0, 1, 0, 1, 1 base 2. Remainder. Because this is not equal to 0, that means the remainder is 1, 1 base 2. Next example. We have 306 divided by 5 base 6. Using long division method. 302 base 6. What are we going to do first? What are the digits used for base 6? That is 0 to 5. 5 times 0, 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5. 5 times 2, that is 10. 10 is greater than the base because we have our base to be 6. So we have 10 divided by 6, that is 1 remainder 4. That means that 5 times 2 in base 6 is 1, 4. 5 times 3, that is 15, and it is greater than what? Greater than our base. 15 divided by 6, that is 2. Remainder 3. 5 times 4, that is 20. 20 divided by 6, we have 3, remainder 2. 5 times 5, 25. Divided by 6, that is 4, remainder 1. Now, we start our division. 3 divided by 5 is not possible. We write 0. Join the first 2 digits, that is 30. 30 divided by 5, come to this side. Do we have anything like 30? No, but we have 23 before 30. That means that I will only see 3 of 5 in 30. 3 of 5. 3 of 5 in 30. I will have this to be 3. 5 times 3 will give me 23. Subtract. 0 minus 3 is not possible. We borrow 1 from the next digit. And if we borrow 1 from 3, this will turn to 2. The one that we borrowed, we turn to what? We change to the base. And the base here is base 6. 6. 6 plus the 0 here, that is 6. We now have this to be 6. 6 minus 3, this is equals to 3. 2 minus 2, that is 0. We bring down the next digit, which is 32. 32 divided by 5. 32 divided by 5. 32 divided by 5, that is 4. Because 5 times 4 is 32. We have this to be 4. 5 times 4, 32. Subtract. This is 0, 0. Since we have 0 here, that means that 302 base 6 divided by 5 base 6 is We are not going to write the first 0, 34 base 6, without any remainder. Here we have remainder. We have remainder. We don't have any remainder here. And also, we don't have any remainder here. The next example. 13233 base 4. Divided by 23 base 4. The long division. 1323323. We want to divide 13233 base 4 by 23 base 4. What are the unit digits? Sorry, what are the digits used for base 4? That is 0 to 3. 23 times 0, 23 times 1, 23 times 2, and 23 times 6 times 3. This is 0. This is 2, 3. Now, we want to multiply 23 and 2 together. 23 multiplied by 2. And we are working in what? Base 4. 2 times 3, that is 6. It is greater than our base. 6 divided by 4, that is 1. Remainder what? Remainder 2. We write the remainder. Keep 1. 2 times 2, 4, plus 1, 5. Greater than the base. 5 divided by 4, that is 1. Remainder 1. The first, the remainder, and the 1. So we have this to be 1, 1, 2. 23 times 3. 3 times 3, that is 9. Divided by 4, 2 remainder 1. 3 times 2, that is 6. Plus 2, 8. Divided by 4, that is 2 remainder 0. Write the remainder first. So we have this to be 201. Now let's start our division. 1 divided by 23 is not possible. 3 divided by 20, no. We take the first two digits. 13 divided by 23 is not possible because 13 is lower than 23. We join the third one. That's it. We now have 132. 132 divided by 23. Let's come down to this table. Do we have anything like 132? No. But we have 112. 112. That means that I will see we have 2 of 23 in 112. Sorry, 2 of 23 in 132. 2 of 23 in 132. This will be 2. 23 times 2. We have 112. 112. Subtract 0, 2. This should be 0. Bring down the next digit. 203 divided by 23. Do we have anything like 203 here? No. But we have 201. That means we will have 3 of 23. 3 of 23 in 203. We will write 3 here. 23 times 3, that is 201. Subtract. And we have this to be 2. 0 minus 0, 0. 2 minus 2, 0. We don't have to write it. Bring down the next digit. And what do we have next? That is 23. 23 divided by 23, that should be 1. 23 times 1, that is 23. 0, 0. That means 132, 33 base 4 divided by 23 base 4 is, we will not write this, that is 231 base 4. With this explanation, what is the solution to this FGH? First, second, third. We then move on to discuss radius points or base point numbers. Base points numbers. These are numbers in a base with a point separating integer from fractional parts. Examples: 10.5, 101.11 base 2, 210.011 base 5. Conversion of base points numbers to fraction. How do we convert base points numbers to fraction? Let's have two decimal point numbers. Let's convert 0.53 to fraction. This is equals to, the number after the point is what? 53. So we have 1. How many digits are after the point? That is 1, 2, 0, 0. That means 0.53 is the same thing as 53 over 100 in fraction. 7.101 can be written as 7 plus 0.101. This is equals to 7 plus. What is the number after the point? That is 101 over, we have 1. How many digits are after the point? 1, 2, 3, 0, 0, 0. We are going to use these same ideas to convert other base points numbers to fraction. Example 1, 0.0101. Number after the point is 0101 base 2 over 1. How many digits are after the point? 1, 2, 3, 4. 1, 2, 3, 4. Also in base 2. Note that 01 is the same thing as 1. 001 is the same thing as 1. 0100 is the same thing as 100. The first 0 doesn't count. That means that we have 101 base 2 over 1000 base 2. We will then convert 101 base 2 to base 10 and also 10000 base 2 to base 10. But we don't need to worry about the conversion of the denominator to base 10 because this is the same as 101 base 2 over. The base we have here is what? Is base 2. 2 raised to the power of how many zeros? 1, 2, 3, 4. Raised to the power of 4. We just have to convert the denominator to base 10. To convert 101 base 2 to base 10, 0, 1, 2, we will expand, and that is 1 times 2 raised to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. And this is equals to 1 times 4 plus 0 times 2 plus 1 times 1. 1 times 4, that is 4, plus 0 plus 1. This is equals to 5. We are given 0.0101 base 2. This is equals to 101 base 2 in base 10, that is 5, over 2 raised to power 4, that is 16. And we are done. Example 2. We have 101.0111. What are we going to do first? Separate them. 101 plus 0.0111 in base 2. This is in base 2 and this is also in base 2. This means that 101 plus number after the decimal is what? Sorry, number after the point is what? 0111 over how many digits? 1, 2, 3, 4. The base we have here is base 2. That is 2 raised to the power of 4. We have 101 plus what, as we said earlier, 01 is the same thing as 1. 001 is the same thing as 1. That means we have 111 over this in base 2, base 2. This is also in base 2 over 16. We are going to convert 101 base 2 to base 10. Also, 111 base 2 to base 10. Let's first of all convert 101 base 2 to base 10. 010. You have 4 plus 0 plus 1, and that is 5. 111 base 2. Raised to the power of 0. 1 times 4 plus 1 times 2 plus 1 times 1. 4 plus 2 plus 1, and that is 7. That means that 101.0111 base 2 is equals to 101, that is 5, plus 111, 7 over 16. So this is 5 whole number 7 over 16 in fraction. Example 3. What do we have? We have 32.311 base 5. What we are going to do first is separate the fraction and the integer. This is 32 base 5 plus 0.311 base 5. And we have 32 base 5 plus number after the point, that is 311 base 5 over the base here is what? That is 5. How many digits are after the point? 1, 2, 3. 5 raised to the power of 3. So let's convert 32 base 5 and 311 base 5 to base 10. 0, 1, and this is 3 times 5 raised to the power of 1 plus 2 times 5 raised to the power of 0, and this is 3 times 5. This will give us 15 plus 1, sorry, plus 2, and that is 17. 311 base 5. 3 times 5 to the power of 2 plus 1 times 5 to the power of 1 plus 1 times 5 to the power of 0. This is 5 squared, that is 25. This is 3 times 25, we have 75, plus 5 plus 1. This will give us 81. So what do we have now? 32 base 5. And what is 32 base 5? That is 17. Plus 311 base 5. That is 81 over 5 raised to the power of 3. This is equals to 17 whole number 81 over 125. So the fraction of 32.311 base 5 is 17 whole number 81 over 125. Example 4. 21.12 is 3. Let's separate the integer from the fractional. 21 base 3 plus 0.12 base 3. This is point. Number after the point, that is 12 base 3 over how many digits do we have after the point? That is 2. And our base is what? 3. 3 raised to the power of 2. Let's convert 21 base 3 and 12 base 3 to base 10. This will give us 2 times 3 plus 1 times 1. And we are going to have 6 plus 1. This is equals to 7. 1, 2, base 3. Three plus 2, that is 5. So therefore, we have 21.12 base 3 is equals to 21 base 3. 21 base 3 is 7 plus 12 base 3, that is 5 over 3 raised to power 2, that is 9. This is equals to 7 whole number 5 over 9. The fraction of 21.12 base 3 is 7 whole number 5 over 9. What will be the solution to 5 to 8? Conversion from decimal point numbers to base points. Convert 3 over 4 to base 2. To base 2. We want to convert 3 over 4 to base 2. What do we have to do? First thing we have to do here is check the denominator. The denominator is 4. Can we write the denominator as the power of the base we want to convert it to? We have this to be base 2. 4 can be written as 2 raised to the power of 2. Since we can write the denominator as the power of the base, that means all what you need to do is convert 3 to base 2 and 4 to base 2. Convert 3 to base 2. This will be 1 remainder 1, 0 remainder 1, 1, 1 base 2. And to convert 4 to base 2, that is 2 remainder 0, 1 remainder 0, 0 remainder 1. That is 100 base 2. 3 over 4 is equals to 1, 1 over 1, 0, 0. And this is equals to, how many zeros do we have at the denominator? That is 2. Start from the right. 1, 2. We are going to have points here. That means 0.1, 1. But for the integer part, that will be 0. That means we have 3 over 4 is equals to 0.11 base 2. This is the first method. What of if the denominator cannot be written as the power of the base? What we have to do is change this fraction to decimal point number. 3 over 4 is equals to 0.75. Now this is what we want to use. 75, and this is the 0 point. We want to convert 0.75 to base 2. That means multiply this by 2. 2 times 5, that is 10. 0, remainder 1. 2 times 7, that is 14. Plus 1, that is 15. We write 5. The one that remains, bring it out here. Don't join it to this, so bring it out here, because how many digits do we have here? 1, 2. It's this one too must be the same digit. 1, 2. Again, multiply by 2 until we reach 0. This is 2 times 0, 0. 2 times 5, that is 10. Remainder 1. So that one, bring it out here. So we have reached 0 here. That means that 3 over 4 is equals to 0.11. Here we move downward. 0.1111 base 2. Let's take a look at another example. We have this to be. We want to convert 7.75 to base 2. What do we have to do here? This is equals to 7 plus 0.75. Because we have to convert this to base 2 and also convert this to base 2. Let's convert 7 to base 2. 3 remainder 1, 1 remainder 1, 0 remainder 1 upward. So that means 7 is equals to 111 base 2. We want to convert 0.75 to base 2. 0.75 times 2, we multiply it by 2. 2 times 5, that is 10. 0 remainder 1. 2 times 7, that is 14, plus 1, 15. How many digits do we have here? 7550. The remaining digits, bring it here. Times 2 again. 2 times 0. 2 times 5, 10. 0. Remainder 1. Bring that here. Since we have reached 0, that means that 0.75 is 0.11 base 2. So we have 7 plus 0.75 equals to 111 base 2 plus 0.11 base 2. And that will be 111.11 base 2. Another example. Convert 0.5625 to base 3. We want to convert 0.5625 to base 3. What are we going to do? We will multiply this. Look at the integer here. The integer is 0, so we don't have to separate. If the integer is greater than 0, we can separate. But here the integer is 0. But here the integer is 7, so we have to separate. We have to use plus. So we multiply by 3 because we want to convert this to base 3. 3 times 5, that is 15. 5, remainder 1. 3 times 2, that is 6, plus 1, 7. 3 times 6, that is 18. Keep 1. 3 times 5, that is 15, plus 1, that is 16. The one that you have to keep, write it here. Again, multiply by 3. 3 times 5, that is 15. Keep 1. 3 times 2, that is 21. Plus 1, 22. We write 2. We keep 2. 3 times 3, that is 24. Plus 2, that is 6. 24 plus 2, that is 26. We write 6. We still keep 2. 3 times 6, that is 18. Plus 2, 20. We write 0. We bring out 2. Because the digit we have here is 1, 2, 3, 4. Our result here must not exceed 4. 1, 2, 3, 4. 1, 2, 3, 4. Multiply by 3 again. 3 times 5, 15. Keep 1. 3 times 2, that is 6, plus 1, 7. 3 times 6, 18. Write 8. Keep 1 again. 3 times 0, that is 0, plus 1. We don't have anything. Remain, right? This should be 0. Multiply by 3 again. 3 times 5, that is 5. Keep 1. 3 times 7, that is 21. Plus 1, 22. We keep 2. 3 times 8, that is 24. Plus 2. We have what? We have 26. We keep 2 again. 3 times 1, that is 3. Plus 2, that is 5. We still don't have anything remaining. This should be 0. Multiply again by 3. Mind you, until we get to 0, right? 3 times 5. This is 3 times 2. We have 6 plus 1, 7. 3 times 6, 18. 3 times 5, 15. 6. Bring 1 here. But notice something. We have 5625. Okay, so we have 5625, which is this. We have 6875. which is this. That means that if we continue to multiply by 3, you can see that what we have here is 1. If we continue to multiply by 3, the next one will be 2. The next one will be 0. The next one will be 0. The next one will be 2. That means that 1 to 0, 0, we keep repeating. This implies that the base 3 of 0.5625, the base 3 of 0.5625 is 0.1200. 0.1200. But this 1200 keep repeating. We have this. This means that 1200 keep repeating in base 3. If, for example, we only have 0. We have 1, 2, 3, 4, 3, 4, 3, 4. This is what we have. What we are going to write is 0. Let's say this is 3, 4, 3, 4. Let's say we are working with base 5. What we have to write is 0.1234. But this 3, 4 keep repeating. 3, 4, 3, 4 keep repeating. We are going to put that bar on top only 3, 4. 3, 4, because it is this 3 and 4 that keep repeating. So that is what we have here. 0.5625 base 10 to base 3 is 0.1200. And this 1200 keep repeating. The next example. We have convert 9.648 to base 5. 9.648 to base 5. We want to convert 9.648 to base 5. So we can write this as 9 plus 0.648. Convert 9 to base 5.